हेलो स्टूडेंट्स, वेलकम टू द बोरिंग स्कूल, जहां हम केमिस्ट्री को याद नहीं करते बल्कि समझते हैं। एंड आई एम ऋषभ सर, सीनियर केमिस्ट्री फैकल्टी, एंड मैं यहां पर हूं टू क्लियर ऑल योर बेसिक फंडामेंटल्स विच आर रिक्वायर्ड टू अंडरस्टैंड केमिस्ट्री ऑफ क्लास 11th एंड क्लास 12th। सो तुमने एक चीज नोटिस किया होगा दैट जब भी हम एग लेने जाते हैं, बनाना लेने जाते हैं, तो हम ये बोलते हैं कि आप मुझे 1 डजन दे दो, 2 डजन दे दो, 3 डजन दे दो। सो बेसिकली जो नंबर ऑफ बनानाज या नंबर ऑफ एग्स मुझे जो खरीदने हैं, मैं वो नंबर न बोलकर एक टर्म बोलता हूं जो है डजन। तो ये डजन क्या रिप्रेजेंट करता है? तो ये डजन रिप्रेजेंट करता है 12 नंबर के लिए मैं वर्ड यूज करता हूं डजन। सेम वे मुझे अगर 144 नंबर बोलना है तो मैं उसके लिए एक टर्म यूज करूंगा ग्रॉस। सेम वे जब केमिस्ट की बात आती है तो उनके पास होते हैं एटम्स, उनके पास होते हैं मॉलिक्यूल्स। तो उन एटम्स और मॉलिक्यूल्स को के नंबर को रिप्रेजेंट करने के लिए जो टर्म हम यूज करते हैं उसको हम बोलते हैं मोल। तो जैसे 12 मतलब 1 डजन होता है, वैसे ही हमें समझना है कि ये मोल का मतलब क्या है। तो चलिए लेट्स अनलॉक द मिस्ट्री बिहाइंड द केमिस्ट्री ऑफ 1 मोल और द मोल concept. So this lecture is basically for all those students who are moving from class 11th class 10th to class 11th. So this will be basically a bridge course for the students who are clearing class 10th, are going to take admission in class 11th for either JEE preparation or NEET preparation, or those who are preparing for boards. So this will be useful for all the students. In this lecture, I'll be mostly using English, but in between some Hindi I can also, or I will also use. So let's start the chapter. So let me welcome you to this series, and our first topic of the day is mole concept. So as I have told you that 1 dozen is equal to 12. So 1 gross is equal to 144. So same way I have told you that chemists use 1 mole to represent the number of atoms or number of molecules. Now what is this 1 mole? This is equal to what? Or how do we define 1 mole? So let me tell you the definition of 1 mole first. It is defined as it is equal to that number of entities, it is equal to that number of entities which is equal to the number of atoms, which is equal to the number of atoms present in 12 grams of C12 isotope. So this definition says if I'm taking 12 gram of carbon 12 isotope, then that 12 gram has whatever number of carbon atoms that will be equal to 1 mole. So this 12 gram of carbon 12 has how many atoms that we have to find. So mass of 1 atom of carbon 12, mass of 1 atom of carbon 12, that is approximately equal to 1.99 into 10 to the power minus 23 gram. This is mass of 1 atom of carbon 12. So next question is, how many atoms are present in 12 gram of carbon 12? So we can take a simple example. Let's say I have a bag. The weight of bag is 100 kg, and that bag is filled up with balls, and weight of each ball is 2 kg. So we have to find that how many balls are present in the bag. So it's very simple that 100 kg is the total weight and 2 kg is the weight of one ball. So 100 by 2, that is total 50 balls are present in that bag. Same way we can see over here that the weight of carbon 12 is 12 gram, and weight of each carbon 12 atom is 1.99 into 10 to the power minus 23. So if I have to find number of atoms of carbon 12, number of atoms of carbon 12, so that will be equal to 12 divided by 1.99 into 10 to the power minus 23. So on simplifying this, we'll get it as 6.023 into 10 raised to the power 23. So as 12 gram of carbon 12 is having 6.023 into 10 to the power 23 atoms of carbon 12, that is why we write 1 mole. That is why we write 1 mole is equal to 6.023 into 10 to the power 23 entities. So you can see this number is very, very big. This number is very, very big. 6.023 into 10 raised to the power 23. So this is 1 mole. Now, we have understood that why 1 mole is this number. The reason is it is equal to the number of carbon atoms which is present in 12 gram of C12 isotope. Now, let's say there are 2 moles of sand grain. Let's say they are saying there are 2 moles of sand grains. What is the number of sand grains? What is the number of sand grains? Let's say it is given that there are 2 moles of sand grain and they're asking what is the number of sand grain. So we know that 1 mole will have 6.023 into 10 raised to the power 23 sand grains. So 2 mole will have 2 into 6.023 into 10 to the power 23 sand grains. So if the number of moles is known, we can easily calculate the number of entities. Okay, one more important point, that this number 6.023 into 10 raised to the power 23, this number is also known as Avogadro's number. This number is also known as Avogadro's number. This is also known as Avogadro's number. And this is represented by Na or NO. So this is how we represent Avogadro's number, which is equal to 6.023 into 10 raised to the power 23. So students, if you are not having your notebook with you, then please go and bring your notebook and keep solving the questions which I am giving. You should also try to write everything which I'm writing over here. You should pause the video and you should write everything. And if any question is there, then those questions you should try by yourself. Then only you will be able to understand how to approach a new question when it is coming in any examination. Okay, so let's take one more question. Question says, during decomposition of certain amount of calcium carbonate. During decomposition of certain amount of calcium carbonate, 2 moles or let's say 3 moles of CO2 gas is produced. 3 moles of CO2 gas is produced. Find the number of molecules of CO2 gas produced. So it is again similar question. What we can do, that we know 1 mole of CO2 will contain 6.023 6.023 into 10 to the power 23 molecules. So 3 moles of CO2 will contain 3 moles of CO2 will contain 3 into 6.023 into 10 to the power 23 molecules. Okay, so this is how we can find the number of molecules or number of entities if moles of entity is given. So using this, we can find a general formula also, that this is nothing but number of entities. So I can write number of entities. It can be atoms, it can be molecules, it can be anything whose mole is given in the question. So number of entities is equal to 3 is what? 3 is moles of entities. So I can write number of entities is equal to moles of entities into the 6.023 into 10 raised to the power 23 is nothing but the Avogadro number. So I can write moles of entities into Avogadro's number. Avogadro's number. So from here I can simply write that moles of entities will be equal to number of entities upon Avogadro's number. Number of entity upon Avogadro's number. So this is how we calculate the moles of entities if what is given? If number of entity is given. Let's take one more question. Question is, find the number of moles of H2O molecule. Find the number of moles of H2O molecule if it contains 12.046 into 10 raised to the power 20 molecules of H2O. So you can see in this question what is given? They have given the number of molecules of H2O. And what they're asking? They're asking moles of H2O. So we know the formula that number of moles. What's the formula? Number of moles of H2O molecule. Number of moles of H2O molecule will be equal to number of H2O molecules divided by Avogadro's number. Now, number of H2O molecules given is 12.046 into 10 to the power 20. Upon we know Avogadro's number is 6.023 into 10 to the power 23. So on simplifying this, we'll get it as 2 into 10 to the power minus 3 moles. So we have 2 into 10 to the power 3 moles of H2O. Okay. Next question. Find the charge on 1 mole of electron. Find the charge on 1 mole of electron. So how will you find the charge on 1 mole of electron? So we know charge on 1 electron is how much? So it is 1 negative charge. 1 negative charge in coulomb, it is 1.6 into 10 to the power minus 19 coulomb. So I can write charge on 1 electron. Charge on 1 electron is equal to 1.6 into 10 to the power minus 19 coulomb. So charge on 1 mole electron, or we can write charge on 1 mole means how many electrons? Na electrons, that is Avogadro's number of electrons, which is nothing but 6.023 into 10 raised to the power 23. So I can write charge on 6.023 into 10 to the power 23 electron. That will be equal to 1.6 into 10 to the power minus 19 into 6.023 into 10 to the power 23 coulomb. This will be charged on 1 mole of electron. That approximately will be equal to 96500 coulomb. This is charge on 1 mole of electron. And this charge on 1 mole of electron is also known as 1 Faraday. This charge on 1 mole of electron is also known as 1 Faraday. Okay, let's take one more question. Question is, find the number of electrons in 2 mole of N-3 ion. We have 2 moles of N-3 ion. You have to find that how many electrons are present in 2 moles of N-3 ion. So how can we approach this question? So first point which we know, that 1 ion of N-3 will have how many electrons? So we know that nitrogen has 7 electrons. 3 negative charge means it has gained 3 more electrons. If it has gained 3 more electrons, it means there will be total 10 electrons. So 1 ion of N-3 will have a total of 10 electrons. This is first information which we should have with us. Second thing is, we have 2 moles of N-3. So if I am able to find that how many N-3 ions are present, then we can find that how many electrons will be present in those many N-3 ions. So we know that number of ions will be equal to moles of ions into Avogadro number. This formula we have already discussed. So number of ions will be equal to moles, which is 2, into Na. So this is number of ions. Now 1 ion has 10 electrons. So number of electrons in 2 Na ions will be equal to how much? That will be equal to 2 Na into 10. Why we are multiplying by 10? Because 1 ion will have 10 electrons. So number of electrons in 2 Na ions will be 2 Na into 10. Okay. So I hope this question is also clear to you. Now moving next. We have one more term, that is atomicity. Atomicity is nothing but the number of atoms which are present in one molecule. Atomicity is number of atoms present in one molecule. So let me write, it is the number of atoms, present in one molecule. For example, if we say O2, then O2 has 2 oxygen atoms. So its atomicity is 2. If I'm saying N2, so N2 again has 2 nitrogen atoms. So atomicity is 2. If I write O3, O3 has 3 oxygen atoms. So atomicity is 3. CH4, so CH4 has 1 carbon atom and 4 hydrogen atom. 1 carbon, 4 hydrogen. So total 5 atoms are present. If I say H2SO4, so H2SO4 has 2 hydrogen atom, 1 sulfur and 4 oxygen. So in total there are total 7 atoms. Let's say HNO3. So HNO3 will have 1 hydrogen, 1 nitrogen and 3 atoms of oxygen. So in total there are 5 atoms. So this number of atoms which is present in one molecule, that is known as its atomicity. Number of atoms present in one molecule is known as atomicity. Okay, so let's take some question on the concept of atomicity and number of moles. Okay, so first one question which we can write is, find the number of oxygen atoms, present in 10 molecules, present in 10 molecules of H2SO4. So what we know is that one molecule of H2SO4, one molecule of H2SO4 will have how many oxygen atoms? So it will have 4 oxygen atoms. One molecule of H2SO4 will have 4 oxygen atoms. So 10 molecules which they have asked in the question, 10 molecules of H2SO4 will have how many oxygen atoms? So it will be 4 into 10 oxygen atoms, which is equal to 40. So 10 molecules of H2SO4 will have 40 oxygen atoms. Let's take one more question. Find the total number of atoms present in 50 molecules of H3PO4. So how will we solve this question? So we can see that one molecule of H3PO4 will contain 8 atoms, out of which 3 are hydrogen, 1 is phosphorus and 4 are oxygen. So there are total 8 atoms in one molecule. How many molecules we're having? We're having 50 molecules of H3PO4. So 50 molecules of H3PO4 will have 50 into 8 atoms, which will be equal to 400 atoms. Is it clear? Let's take one last question. Last question is, find the total number of atoms present in 2 moles of CO2 molecule. Total number of atoms present in 2 moles of CO2 molecule. Now again, how will we approach this question? So first thing which we know is one molecule of CO2 will have in total 3 atoms. One molecule of CO2 will have 3 atoms. So if I have to find total number of atoms, then first we have to find that how many molecules of CO2 are present in the given amount. So we have 2 moles of CO2. So we know one number of CO2 molecule. The formula we know that number of CO2 molecule is equal to number of moles of CO2 molecule. Number of moles of CO2 molecule into Avogadro's number. Number of moles of CO2 molecule into Avogadro's number. So how many moles of CO2 molecule is there? 2. So 2Na is the number of CO2 molecule. Now again we can use the relation that one molecule of CO2 contains 3 atoms. One molecule of CO2 contains 3 atoms. So 2Na molecule of CO2 will contain how many atoms? So that will be 2Na into 3 atoms. That is equal to 6Na atoms. So like this, we can have quotients based on the relationship between the number of entities and mole of entities. So what we have understood, that mole is equal to 6.023 into 10 raised to the power 23. This number is selected because it is equal to the number of atoms which is present in 12 gram of carbon-12 isotope. And the formula to calculate number of moles was number of moles of entities is equal to given number of entities upon Avogadro's number. So I hope the basic concept of this calculation was clear. If you have not understood any question, then you can comment and I will respond to your comment by few more examples to explain your doubts. Keep practicing question, keep learning. Thank you.